Hi everyone, welcome to part 2 of our tutorials on how to create data dictionaries or code books for your research projects. So the first part we learned about Codebook, which is the online version of Codebook, which allows you to create these sort of data dictionaries and HTML reports. This one we're going to show you Data Schema, which was created from an idea from the R Open Science group, and we rewrote this using a Shiny app so that people who are like graphical user interfaces and maybe don't want to work in R or Python can enter their data through this type of app rather than having to learn code. And so what we've done here is I have already pre-worked an example, and I'm going to just walk you through how I did it. And so all of these, it has some descriptions here at the top that explains what the purpose of the app is. And we're going to be working with a data set that is the motor trend car information for like 30 some odd cars and like 10 or 11 variables. So you can upload data in text, CSV, Excel, SAS, and SPSS format. So you just click Browse, pick the file that you're interested in, and it will upload that file for you. Okay, and then down here in this preview, I can walk through and make sure it just is the data I was expecting it to be. Now, the key thing for this particular app is to go through these pieces in order. So I'm going to hit Edit Attributes and work through them one at a time. Because otherwise, once you get towards the end, if you skip around, it may not like you very much. And so with this, I want to enter its attributes. Well, what are attributes? Attributes are described down here at the bottom. The file name you'll leave alone. The variable name is the name of the measured variable. This is the column name in your data set, so leave that alone as well, so it will match the actual data. You can provide some sort of description of the variable. So I pulled this from the descriptions available in RStudio. And then I also included the unit text. This could be a lot of different things. It kind of depends on what type of data that you're using. Here I labeled them mostly as numeric and positive. For cylinders, I mentioned that it's only 246. This is cubic inches. So this could be in milliseconds, or it could be an explanation of the Likert scale that you're using. So it's either, like for the example, this categorical one, it tells you what 0 and 1 stand for. So these are kind of value labels if you're an SPSS person. But once you're done with this, you'll hit Save Changes. And this will allow you to save an attributes CSV file. So let's look at what that looks like. And all of these outputs, until we get to the end here, will be CSV files that are basically the same table that you entered all the data in. The advantage to this is that you could edit these directly. Then I would move on to the Edit Access page. The Access page is sort of where do people find the data. So leave the file name alone, give the file name a better data, so I called it the motor trends car data. A URL that the data is available at, so I could put our specific Open Science page where the data is actually linked. Here I included the link for the R manual where I pulled all this information from, but you could link to the data or more information about the data. And then the file format is the saved information of the extension of the file. So we want to be able to be sure to hit Save and save that file. Under Edit Bibliography, this is going to be the information about the data itself, not the creators of the data. That's the next tab. So the title is the title of the data set, so I just left in empty cars. I copied the description from the R help guide to describe the data. The original time this was published was 1981 as part of this data set. Now, it was originally published in the 70s in the Motor Trends magazine, but I included the date published from the publication here. Now, in all of these, since I'm not showing you this, you can double click on them and edit and type in them directly. Okay, tab, kind of like Excel. I cut and pasted the citation from where this came from, but this could be how to cite the data, if it's your data, how you want others to cite it. Keywords here that will help for searchability. You can pick a license. I just put in MIT here, but there are specific license codes that you can use. And then any other information about funding. Geographic description would be the spatial coverage metadata. This would be things like cities, towns, states, countries, areas of the world that you collected this data set, when you started and ended the data collection. Okay. And those dates, so here I've already screwed this up. This date should be in ISO format, so I could just kind of make up a specific date for that publication. So I want to hit Save Changes and save that file. Okay, so any edits when you make them, be sure you hit Save Changes. The creators is you, basically. So the first column is your ORC ID. ORC IDs are kind of like barcodes for researchers. It allows you to distinguish who you are versus other people. So I've got myself pulled up here, and you would include just the last component of the ORC ID. These are free for you to use, and they allow you to create sort of like a CV for yourself. And so I would cut and paste this 16-digit code over here. Okay. Now, I did not make this data set, but I created this data dictionary. So it's kind of up to you on how you treat the data collection here. So I put in my given name, my affiliation, and then I would put in my email. Once you've used every single page here and hit Save Changes, you can then move on to the JSON report. JSON is a machine-readable format that is advantageous because computers can read its structure, and it allows for like nesting of the different types of information that you have on each page. So it takes all of those CSVs and combines them into one, basically. Now, it's not very pretty here, but this is the output. Mainly this piece here is so that you can see that it's ready to save. If there is no text here, you have skipped one of these pages and you need to go back and be sure you enter the data and hit save on every single page. So once you hit save on every page, this will pop up with some text. If there is no text here, it will give you an error message and basically quit on you. So here I would click Save JSON File. So let me go to my Downloads folder here. And I'm gonna, most people's computers, this will open automatically with usually a browser. Mine defaults to a code editing thing that you don't want to see. So let me pull that over here. And the reason that people and computers like JSON is because it's very structured. So I closed all of them, but you can also hit Expand All here and see how it's structured. Here, let me hit Collapse. So under creator, it's got my name, but there could be more than one creator, so you can add extra ones. Under description or keywords, it's got all of them. So it kind of like stacks the information, especially under variables measured. So here's that first one. The type, the name is miles per gallon, and the description is miles per gallon, and it's numeric. And so that's one reason that JSON has that advantage. This particular format is in schema.org and is specific to dataset types. But if you're not really into reading structured files, you could also print out an HTML report of the dataset that is a bit prettier to view. So you'd hit Save HTML report, Save File, and then we could look at what that looks like. And so this is an example. So I could go back and fix these. The little symbol did not translate correctly where I cut and pasted. But this would be all of that same CSV information in a nice HTML report for you to include online as well. And so main key thing to take away here is that you can enter lots of different information pieces, but be sure you do them in order and hit save on each page so that once you get to these last couple of pages, they will print out nice for you.